All right, everyone, welcome. So we live in a world where business basically runs on data, right? But have you ever stopped to think about how that data actually gets from, say, your laptop to a server halfway around the world? I'll give you a hint, it's not magic. It's actually a fascinating set of rules, protocols that can literally make or break a company. And that's what we're here to do. This quick explainer is going to give you the essential framework you need before you even crack open Chapter 4.
So let's just jump right in with a super common scenario. You've got an employee, they're working from home, and they need to get into a really sensitive company database. How do you make that happen? I mean, how do you make that connection not just seamless, but totally secure and reliable? Well, the answer is all in the invisible rules that run the internet. And let me tell you, if you master these rules, you're not just prepping for a job at the help desk, you're building a skill set that takes you all the way to the boardroom. Okay, so here's our game plan for this little primer. First, we're going to talk about what I call the digital handshake, the protocols themselves. Then we'll dive right into the core of how the internet actually talks, using something called TCP/IP. After that, we'll shift gears to securing and accessing data, and we'll even peek inside a network detective's toolkit. And we'll wrap it all up with your specific mission for when you tackle Chapter 4.
All right, let's get right into it. Section 1, Protocols. You can think of these as the silent, invisible agreements that make our entire digital world even possible. So let's take a closer look.
So what exactly is a protocol? Well, the best analogy is to think of it as grammar, but for digital conversations. You know how we need grammar to make sense when we talk to each other? It's the exact same idea for computers. Devices need protocols to communicate. Without that shared language, the internet would just be chaos, a digital Tower of Babel. And this isn't just some abstract, theoretical concept. I mean, it's literally happening right now as you stream this video. The engine making it all possible is a whole suite of protocols called TCP/IP. It's not just one thing, it's a team of protocols all working together to get this content onto your screen. Each one has a super specific job, and when you put them all together, that's what makes the internet work. Okay, so when we talk about TCP/IP, we get to a really crucial choice that has to be made. And honestly, it's a classic business trade-off that you'll see everywhere. What's more important, reliability or speed? So let's break down what that actually means in the real world. This is where it gets really interesting. On one side, you have TCP, the Transmission Control Protocol. The best way to think of this is like a certified courier package that you have to sign for. It's all about guaranteeing delivery, making absolutely sure every single piece of data arrives, and in the right order. This is what you'd use for, say, a bank transfer. You can't lose a zero, right? But then, on the other hand, you've got UDP, the User Datagram Protocol. This is more like sending a standard postcard. It's way faster, super efficient, but there are no guarantees it'll get there. This is perfect for something like video streaming or online gaming, where losing a tiny packet of data here and there won't ruin the whole experience. Okay, so we've figured out how to get the data moving. That's great. But how in the world do we keep it safe? Let's go back to our employee working from home. They can't just be sending sensitive company files over the public internet. That would be a disaster. And that, of course, is where security comes into play.
And the absolute heart of that security is encryption. Seriously, the best way to think about it is like a digital secret decoder ring. You take your data, you scramble it all up into a secret code, that's called a cipher, and the only way to read it is if you have this special key to unscramble it. Now, this is exactly how a VPN, a virtual private network, works. It essentially uses encryption to build a secure private tunnel for your data right through the middle of the public internet. The analogy I love is to picture an armored truck driving on a public highway. It doesn't matter who else is on the road, the stuff inside that truck is safe and sound. That's your data inside a VPN tunnel. But what happens when things go wrong? Because they always do, right? You get a slow connection, a link breaks, something just isn't working. This is the moment when an IT professional stops being just a techie and becomes a detective. And, well, every good detective needs their toolkit. I mean, we've all said it, we've all heard it, the connection is so slow. It is probably the most common complaint anyone in IT ever hears, and it becomes your job to figure out why. You have to find the culprit. Is it the person's computer? Is it the Wi-Fi in the building? Or is it a server on the other side of the planet? You need the right tools to actually crack that case. So here are just a few of the essential tools in that detective's kit. First, you've got netstat. That basically shows you all the active connections, who your computer is talking to right now. Then there's traceroute. This one is like a GPS for your data packets. It shows you every single hop your data takes to get to its destination, which is perfect for finding where the slowdowns or bottlenecks are.
And for the real deep dive, you've got tcpdump. This one lets you actually capture and look inside the network packets themselves. Honestly, learning to use these tools is what takes you from being a network pro to a network hero.
All right, so now you've got the big picture view. You see how all these pieces fit together. So now it's time for your mission. As you sit down to read Chapter 4, I want you to really focus on these specific key concepts.
First, you absolutely have to master the CIA triad. That's confidentiality, integrity, and availability. Ask yourself why this is the bedrock of all security. Next, really dig into the difference between symmetric and asymmetric encryption. What are they, and when would you use one over the other? Then, pay super close attention to the SSL/TLS handshake. That's the series of steps that secures pretty much all your online shopping and banking. It's the magic behind that little padlock icon in your browser. And finally, take a look at the different VPN tunneling protocols. How do things like L2TP and OpenVPN actually build those secure tunnels we talked about? And look, please remember, understanding all of this is not just about learning technical details. This is fundamentally a strategic business skill. Choosing and implementing the right protocols is what enables secure remote work, what makes e-commerce possible, and what protects a company's most critical assets. Knowing this stuff is your ticket to being someone who adds real, tangible value to any organization. So, I want to leave you with one final thought to take with you as you read. We figured out protocols for reliability, for speed, for security. But what's the next great networking challenge? As our world gets more and more automated and connected with the Internet of Things, AI, maybe even the metaverse, what new problems will protocols need to solve? What new rules will we need to invent? That's really the challenge for your generation of innovators. All right, good luck with the chapter.